Hello students, welcome to Sound of Side classes. This is a continuation video of our previous one where we have started just discussing on these properties of carboxylic acid. Now it is to be mentioned here that we have already discussed the physical properties of this carboxylic acid, and now we are going to start with the chemical properties. Now in chemical properties, we will see here that if we take this the structural formula of this carboxylic acid, if we see this, there is 4 attacking site or 4 reacting site. Suppose if we have this compound, if we take this as hydrogen, suppose first is this attacking site. Here this due to this oxygen is more electronegative than hydrogen, there is a chance of dissociation. Next is the attacking nucleophilic attack. Nucleophilic attack at this point. This carbonyl center, this is a electron deficient center, so there also we can have a nucleophilic attack. And also there is another attack for here. This hydrogen is acidic due to electron withdrawing effect of this COOH group. So therefore alkali, we can remove this hydrogen also by using alkali. So these 3 attacking sites are observed in the chemical properties of this carboxylic acid. But the major property is the acidity, this dissociation of hydrogen. So number 1, first reaction is reaction with metal. Here we see that reaction of carboxylic acid RCOH plus Na, this gives us RCONA plus H2. Hydrogen gas is formed. As usual in the reaction with acid and metal, hydrogen gas is formed. That is 2, this one. Similarly, 2 RCOH plus Zn. This gives us RCOO2 Zn plus H2. This compound. Similarly, in case of with magnesium, we are getting RCOO2 Mg plus H2. So these are the common reactions of carboxylic acid with metals. They react with metals to form corresponding magnesium salt of that acid and hydrogen gas. So this is the if we take specific example, suppose CH3COH, this is acetic acid, and plus zinc, that is CH3 CO2 Zn plus H2. So this is our zinc acetate. Zinc acetate plus hydrogen. So in this way, other metal acetate is also formed. This is, if it is there sodium, then we will get sodium acetate. If it is magnesium, then we will get the magnesium acetate. Now next is reaction with metal hydroxide and carbonates. Reaction with metal hydroxides and carbonates. Now similarly, reaction with metal hydroxide, that is an acid-base reaction, and that can take place that can take place here, and to give us salt and corresponding water. And with metal carbonates or bicarbonates, they form the corresponding carbon dioxide, sodium carbonate or sodium bicarbonate, the corresponding sodium salt, carbon dioxide and water. So the general reaction is CH3 COH plus NaOH. This gives us CH3 CONa plus water. Similarly, if we have CH3 COH plus Na2 CO3, then we are getting CH3 CONa plus CO2 plus H2. This will be 2. This will be also 2. Similarly, with CH3 COH plus NaHCO3, this gives us CH3 CONa plus CO2 plus H2O. So these are the reactions with generally sodium hydroxide, sodium carbonate, sodium bicarbonate. In this case, it is corresponding acetate and water, and in this case, corresponding acetate, carbon dioxide and water. These are the products. And similarly, if we take this corresponding magnesium salt, then we get the corresponding magnesium acetate and magnesium acetate, carbon dioxide and water. So these are the common reactions where we prove that where we are getting the acidic property of this carboxylic acid. Now they can show acidity, and the acidity of this carboxylic acid can also be observed when these amines, which are basic in nature, they react with this carboxylic acid. Suppose if we have this compound, CH RCOOH plus NC2H5 C2H5 C2H5. Here is one lone pair. Now this reaction here, this due to this lone pair, the dissociation of this proton that attacks at this lone pair of nitrogen, and we are getting this compound RCO minus plus NC2 C2H5 C2H5 C2H5H. This is plus. So this is the this is our trimethyl amine, and this is the triethyl amine ammonium salt. Triethyl amine. This is called the triethyl ammonium ion. So this is also a type of acid-base reaction which we observe when this triethylamine is treated with corresponding carboxylic acid. Now our next properties is number 3, that is heating of salt of carboxylic acid. Now in the salts of carboxylic acid, when heated in different conditions, they produces different products. Suppose if we have RCONA, sodium salt of this carboxylic acid, when this is heated with sodium hydroxide, NaOH and calcium oxide, this mixture is called soda lime. We are getting corresponding RH plus Na2CO3, sodium carbonate. So corresponding alkane is produced. So if for specific example, if we take CH3CONA, sodium acetate, and it is treated with sodium hydroxide and calcium oxide, so we are getting methane plus Na2CO3. Similarly, if we have ammonium salt, this is a type of reaction. Another type of reaction is when ammonium salt RCONH4, this is plus and this is minus. Ammonium salt, it is also when heated. We are getting RCONH2 plus water. So corresponding amide is formed, amide, and this is the ammonium salt. See, suppose example, if we take the example, suppose CH3CONA, this when heated we are getting CH3CONH2 plus water. This is acetamide, and this is NH4 plus. This is ammonium acetate. So ammonium acetate, when heated we are getting corresponding amide, acetamide, and water. So in these cases, we are getting two different products. In case of sodium salt, we are getting corresponding methane or alkane. In case of ammonium salt, we are getting corresponding amide. And if we use here P2O5, phosphorus pentoxide, which is a strong dehydrating agent, so we will get the corresponding cyanide, CH3Cl, methyl cyanide. Corresponding cyanide will be formed. So this is also another type of reaction where from this salt, after dehydration, we are getting the corresponding cyanide. Now this compound is methyl cyanide. Now another method of preparation is another properties of this carboxylic acid salt. That is, if we have these compounds CH3, C double bond O, Ca, C double bond O, CH3. This is our calcium acetate. This on dry distillation, this gives us corresponding CH3CO, CH3. This is acetone. So calcium salt of carboxylic acid on dry distillation gives us acetone. And another is this potassium salt. This is number 4, I think, and this is number 3, and this is D, I think. And E, the potassium salt, of carboxylic acid on electrolysis produces alkane and corresponding carbon dioxide. Suppose if we have this compound CH3COO minus K plus, this salt, this is when electrolyzed, then at anode what we get is that CH3 CO minus electron, this gives us CH3 CO free radical, and this CH3 CO free radical, two molecules, gives us corresponding CH3 plus carbon dioxide. So we are getting methane and carbon dioxide at anode, and at cathode this potassium is discharged at cathode, and it is reacting with water to give us potassium hydroxide and hydrogen. So this is another type of reaction of this salt of carboxylic acid, where it is when electrolyzed it gives us corresponding alkane and carbon dioxide.